Students, I'm going to go through 6 problems in this packet. 2 of the problems are simply examples that seem to be rather difficult. I had about 20 or so students in my classroom yesterday, last Thursday, the 9th of August. Bless their hearts, they came in for extra help, and we worked together. So there's a couple questions that have seemed to give everyone collective grief. And then there's 3 problems in which there's typos in the answer key that I'm going to fix here. The one problem that seemed to be giving students the most grief would be these exponent things. So we're going to do number 9 together. Let me recap some exponent rules. You might want to put this in the margin. Any exponent to the 0 power is just going to be a positive 1. Okay. The next thing you need to know is anytime you have a negative exponent, for example, x to the negative second, it means to switch either from numerator down to denominator or vice versa. So x to the negative second looks like this. And then if I have this with a negative to the second in the denominator, it means it comes up to the numerator. So that's 3 exponent rules you might have forgotten. So I'm going to start this by using a giant slash bar. And the trick to doing these is exponents expand. So I'm going to start by doing this. Y to the negative 4th, that's negative, so that means now I'm going to go down below. 1, 2, 3, 4. E to the negative 3. That right there, y to the negative 3, that's in the denominator. That means I come up here. That goes down below. All right, now you just clean it up. Do your canceling. So I can cancel. Two x's. Cancel 3 y's, and that's pretty much it. And then you just clean everything up. So at the top, I'm going to have 2x squared. Down below, I have a 3, a y, and 7 z's. So it goes like this: 3y z to the 7th power. There's your final answer. Next one we're going to do here is number 25. Whenever you're dealing with radicals, simplifying, remember this: innies, outies, simplify. So first we look at our innies, see if there's any way we can do anything with this. Now 4 doesn't go into 3, but root 4 is already perfect. So we're just going to take it to its perfect form. So root 4 is 2 over 5 root 3. We're going to multiply top and bottom by root 3. Any radical times itself is just the number on the inside. So this is the complete and final answer. Now, the answer key on the back has this, root 12 over 15. The reason why that's not the complete answer is because root 12 you can simplify a little bit farther. Watch. We're going to prime factor 12. This 2 has a date that's going to come out. Again, you have a date, you get to go out, and we're done. Same answer. Really important that root 3 does not communicate with that 15 because root 3 is inside the radical and 15 is out. Okay, the next one that gave a lot of grief to students was graphing with absolute values. Whenever you have absolute values, you need to know what it looks like. It's going to be a V formation, one way or the other, depending on the circumstances. So whenever there's an absolute value, because all your inputs, even if it's negative, becomes positive, it creates basically a mirrored image. A mirrored image. The easiest way to graph these is just by using a table. The first thing I like to look for are what are called the zeros, the intercepts. So if I have a 0 in the x, what would the y be? That would be called the y-intercept. So if I had a 0 in the y, what would the x be? And that's called the x-intercept. Let's do those first. So if I put a 0 up here in the x, 2 absolute value, of course that's going to be 2. Now the other one, you're asking yourself, if I have a 0 in the y, what would x have to be in order for that to be a true statement? What would x have to be? The only thing that's going to work there is -2. Because -2 plus +2 gives you a 0, which is 0. So those are intercepts. So I'm going to start by graphing those. 0, 2 is right here. -2, 0 is right there. Now I'm just going to choose 2 more points. Let's put a 4 here. So I'm going to put a 4 up there. 4 plus 2 is 6. Absolute value, that means that's 6. I'm going to try -4. So if I can put -4 there, plus 2, that gives me -2. Absolute value still applies with 2. So let's add these 2 points, 4 and 6. And then -4, +2. Okay, so now I think you can see that V formation. So for this, you just, now that you can kind of spot the V, you know that it's going to go like this. You can add more data points if you want, but once you see that V, you can just go ahead and graph it. Okay, the next 3, 37, 40, and 47 actually have typos. The key is incorrect, so that's why we're correcting it right now. 37 says we want to solve the system of equations by elimination. And where the typo is some of the packets did not get this X photocopy. So some of your packets, you don't have an X there. So you need to add it if it's not there. solving by elimination, you want to try to find a way to get rid of both x or y, and because there's only a 1 here, and that's -4, we're going to multiply this whole thing down here by +4. Draw your distributive lines. Now I'm going to bring down the original equation, the other one. Okay, now you can cancel. So the +4x, -4x, that cancels. -12 plus 9y is -3y. -24 plus 9 is -15. So when you solve a system of equations, it's an ordered pair that you're going to get. So your y is now 5. I'm going to take that value of 5 and plug it in right there to solve. So I'm going to have x, and go to the original, -3 times 5 equals -6. Solving systems of equations by elimination. So the fix there was that there should be an x there. The next one we're going to, has an actual typo in it, we're going to fix is 40. And some of your packets should have photocopied. You should have -5/3x. This was the corrected copy. -2. So that's what should have photocopied. And then there's something that was off by the keys. So let's go ahead and show you. If x is less than or equal to -3, first you want to graph all the points where you have -3, comma something. So you want to graph a bunch of points where you have -3 something. So let's graph -3, 0. -3, 1. -3, 2. -3, 3. So you're seeing that y equals less than or equal to -3. Now, because of that equal to sign, we are going to use a solid line. So right now what we have is x equals 3. And if I want x has to be less than, excuse me, x is less than equal to -3, negative there, then you want to shade everything that's less than -3. So this is the side you're shading here. So we're shading. Whenever you have a greater than or less than sign, at some point you're going to be shading. So what I just shaded was technically this. X is less than -3. That's the shading. And the solid line represents x equals -3. Okay, coming to this one, Because that is a less than sign and not equal to sign, keep that in mind. That means your line, whatever it is, has to be dotted. So you start by treating this as if it's y equals mx plus b, because that's what you're used to seeing. So we're going to start by graphing our intercept, which is -2. We're going to count out our slope, which is -5/3. That means my line has to go downward because it's negative. I can go like this. My rise is 5. So I can either go down 5 and over 3, or up 5 over 3. But either way, my line is a negative slope line. Now this is a little bit, whoops, we forgot to dot it here. It has to be dotted. Now, the issue of graphing, you want to choose any 2 points on either side of this line. I like to use points that have 0 in it just to make it easy to work with. So I'm going to choose 1 point to the right of the line, which is 0, 0, and 1 point to the left of the line, which is -10 and 0. Now I plug both of these in, and I ask myself, which one of these is true? -10, 0, or 0, 0. I'm going to do the 0, 0 because that's easy to see. So if I have a 0 in the x, that means I have a 0 there, so I have a -2 on the right is less than, and if I put a 0 here, and you ask yourself, is that a true statement? The answer is no. 0 is greater than -2. That is not a true statement. Not true. Let's check this other one off. If I put I'm not going to use -10, so I'm not going to end up with a bunch of fractions. I'm going to use -9. You'll see why in a moment, why I chose -9. So I'm going to move my point right here and use -9 and 0. You'll see why in just a second. So I'm going to plug in a -9 here. And I get -5 over 3 times -9. All right, and then this is going to be -2. 3 goes in there 3 times, but there's still a negative sign there. So I have 15 minus 2 is less than, and then this is 0 on this side. So I have 0 is less than 13. That is a true statement. So this side, this point right here works. The one on the right does not. So I'm going to shade to the left. So your actual shading should look like this. Last problem here. So Patoa problem, very simple. Let's do this problem together. Have me do. So we're going to label this is our opposite adjacent typo. we have our adjacent. We need our opposite. We ask ourselves what goes with an OA combo, and that, of course, is TOA. Make sure you write exactly this out. Tangent of theta over 1 equals opposite over adjacent. Now we're going to plug stuff in. Our theta is going to be 25 here. Our opposite is x. Our adjacent is 18. Don't touch a calculator until your x is completely by itself. So tangent 25 times 18. Take a look here. Get your calculators out. See if you get the same answer as me. For this one, I'm going to do tangent of 25. Make sure you're in degree mode. Times 18. And you can see your answer there is 8.39. That is different from the key. The key accidentally flipped the input. So this is going to be approximately 8.39. That is different from the key. The key was 38.6. That was incorrect. That incorrect answer came from inverting these. All right, students, I hope you found this helpful. Again, your future Algebra 2 teacher is going to be offering some sort of extra credit, free homework pass, some version of that for you investing in getting this packet done before you walk in through the door.